All right. Now we're going to continue this journey, but we're going to upgrade and do everything that we did with the function vertex form, but now we're going to do it with standard form. So we're going to be graphing this function right here over on the graph. So let's see. F of x is 2x squared plus 4x plus 3. First off, we do need to know the axis of symmetry. We need to know what the vertex is, and the y-intercept is actually a very helpful thing as well, although we're going to use the pattern. We're going to do pattern. So first off, axis of symmetry, the axis of symmetry. Remember, we need to know what the A, the B, and the C are. So A is 2, right there. We know that the B is positive 4. And we know that the C is positive 3, like so. So in order to find the axis of symmetry, we're going to start with our super secret formula, negative b over 2a. And I'm just going to substitute things in. X is negative b, which is 4, all over 2 times the a, which is also 2. So to simplify this is negative 4 over 4, so the answer is negative 1. So that's my axis of symmetry, negative 1. Why is that helpful? Well, because I now know over here I can sketch the axis of symmetry just along the negative 1, where x is negative 1, a vertical line. So I'm going to take this negative 1, and it's got to get substituted to here and to here. So, and this is what it looks like. Since I don't have a y but an f, I can actually write it like this. F of, and we're going to use this negative 1 right there, of negative 1, is equal to 2 times my x, whatever that is, plus 4 times my x, plus 3. So I'm going to substitute the negative 1 into both of those. Actually, all 3 of those, because I have the f of the x in the front. Remember, this simply just means the function whose name is f evaluated at negative 1. It does not mean f times negative 1. So let's simplify this here. F of negative 1 remains the same. Equals, this becomes 2 times 1 because negative 1 squared, minus 4 minus 3. F of negative 1 here becomes 2 minus 4 minus 3. And we end up here with negative 5. So my vertex is negative 1, negative 5. That's the vertex. Here's my axis of symmetry. All right, notice that transcribal errors happen quite often, and so in my case it did. There's a plus 3 here, and I put down a minus because I was minus happy. So I'm going to make a change there, which means this negative 5 is not. It's actually a positive 1. So this guy here is a positive 1. All right, so now let's carry this over, and where's the axis of symmetry? It's at negative 1, where's my vertex? Negative 1, 1. Now, the next step is my pattern. So the pattern is I just take the 2 and I multiply it by the parent pattern 1, 3, 5, etc. So the pattern is 2, 6, 10, etc. So since I'm going in the upward direction, I go up 2, right 1, up 6, right 1, and then up 10. Right 1. So let's do that. Go up 2 right 1 puts me here and reflect it across the axis. Then go up 6, 1, 2, 3, 4, 5, 6, place me there, and I go right 1 to go there, and I reflect it across. As a reminder, when you make your curve, please make sure not to be straight and to might take a few tries to get the nice clean curve, like so. I do want to point out to you right here, C is 3, and look at that right there. That's a 3. And that's perfect, exactly what I expected. C is 3. So when we're graphing this one here, I'm going to start with A equals, B equals, and C equals, and find out that my axis of symmetry is x is negative 2. X is negative 2. So I'm going to go ahead and graph that over here so I have my axis of symmetry. Now I'm going to substitute that negative 2 here, and I'm going to place it into all 3 of those x's up there. Again, that process could be just done completely on your calculator. So h of negative 2 equals the opposite, negative 2 squared, minus 4 times negative 2 minus 3. Again, all that can go into your calculator, but I will show you step by step what does happen here. This becomes the opposite of 4 because negative 2 squared is 4, and that negative comes down. Then we get a plus 8 minus 3, and this here gives me a positive 1. So my vertex is negative 2, positive 1, which now puts me right here for my vertex. Pattern? Well, I know what my pattern is. It's based off the 1, 3 5 pattern, and A is just the negative 1. And I can't ignore the negative because it's going down. So my pattern is 1, 3, 5, but going in the downward direction. So go down 1, right 1, and bounce that across. Down 3, right 1, bounce it across. And I still have room, so let me do down 5 here. And bounce that across. And let me just double check. Notice your C here is negative 3. And notice the C here is negative 3 right there. Make the curve fit, like so. And we are done. Next thing we're going to look at is an application. Let's look here. You and a friend are hiking in the mountains and you want to climb to a ledge that is 20 feet above you. The height of the grappling hook you throw is given by this function. Negative 16 t squared plus 32 t plus 5. What is the maximum height of the grappling hook after you toss it? Can you throw it high enough to reach the ledge? Notice it doesn't mean that you actually make it hook and that you can climb up. We're just saying, is the toss going to be high enough? So that's what we're going to test. A key thing to think about right here is maximum height. If we think about a graph, right? Maximum height. Oh, there it is. That's my maximum height. It has another name. It's called vertex. So when you're asked to find the maximum height or the minimum of a parabola, essentially you're finding the vertex. Now, I don't want to get into too many details here, but these numbers do mean stuff. These numbers do mean stuff. You do not have to memorize what these numbers mean. But I will point out to you the negative 16. You don't have to write this down, but it certainly might be helpful for thinking about. Well, we know A is negative 16. I'll tell you that has to do with gravity. It's negative 16 feet per second per second. That's how fast you accelerate when something is thrown. And notice it's in the negative direction. Why? Because stuff gets pulled down to earth. That's why. The 32, again, you don't need to know what the 32 does. You just need to know how to use it. So B is 32. That has to do with how hard you throw it. The force, let's try not force, the initial velocity. And this last part, we know C means the y-axis. And of course, that's my initial height. Not me as a person, but the initial height of the hook. So that's C equals 5. Now, you don't have to memorize all that, but I do wanted to point out to you that this is a logical formula. It's a logical formula. And you can make changes, too. If you were standing up a little bit higher, then you might be at plus 7. Or if you're throwing it above your head, starting out above your head, it might be a +7. If you throw it harder or softer, the 32 here changes. And if you're on a different planet or you're on the moon, this number here changes. All right, so all we need to do, because ultimately the question is asking me what's the vertex and will it be high enough? So I need to find the AOS first, axis of symmetry. So x equals -b over 2a. So let me substitute these numbers in. So -16 goes abajo, and 32 goes arriba. Double negative is positive. So we end up with 32 over 32, which is 1. One thing we forgot to mention here is what the unit is, right? So my axis of symmetry is -1, but what does that mean? It actually means 1 second. 1 second after throwing this thing, it reaches the highest. So that's 1 second right there. Then it's at the highest height. The question is, how high is it? So we don't know that yet. So I'm just going to calculate that by substituting it into my initial function. So the height is going to be the -16 times the t, which is 1 second, quantity squared, plus the 32 times the t, and then plus the 5 feet. So I'm just going to put that 1 into here and here. You can throw all that in your calculator or do step by step like I'll do right now. 1 squared is +1, no change there, and -16 times 1 is -16. 32 times 1 is 32, so it's positive, and +5 stays. Bring all these together, this is 16 plus 5 is 21. But 21 what? So to finish this up, the height is 21 feet. So let me just interpret real quick what this stuff means. 1 second after throwing the grappling hook, it will be 21 feet high. So I'll write that down as a sentence just for you to see. 1 second after throwing the hook, it is 21 feet high. So that's the question, what's the maximum height? Or that answers the question, that's the maximum height. And the question next says, can you throw it high enough to reach the ledge? And so that, obviously, because I reached 21 feet, which is a foot more than I need, the answer is yes, I can throw it high enough. However, whether you do or not is a completely different skill question. Now let's look at the next problem here. And it is talking about a fountain, 2 fountains. So we've got whoop, 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 little parabola there and a little parabola there. So the first one is represented by this function, -x squared plus 2x plus 8. And the other one is represented by -1/2 x minus 4.5 squared plus 8.5. So these are the trajectories, and the question is which one will reach a higher altitude, A or B. So again, because the question is asking about a higher altitude, we ultimately know that this is our friend, the vertex. The vertex. Well, let's actually start with B, because B is much easier to consider, because this is already in vertex form, which means this puppy right there is my H, and this one right here is my K. So the vertex, we know, is at positive 4.5, whatever that unit is, and then 8.75 is the height. So this right there is the highest it goes. That's the highest height, the max. Yep, so we'll call it that, the maximum. All right, now let's look at A. Well, for A, we need to identify what my A, my B, and my C are. So A is going to be this number in the front, which is a -1. Then B and C. B is going to be this number there, the +2. And C is going to be this number right here, which is a +8. So we're going to use our vertex formula, which starts by finding the axis of symmetry. So the opposite of B divided by 2 times a, which is negative 1. Notice the double negative that we get there, but I'll go ahead and write it all out so you see the negative 2 divided by negative 2 is a positive 1. Okay, next up. Now I need to plug that 1 back into this formula right here. So positive 1 goes there, positive 1 goes there. So let's write that as a of 1, and I'm going to be using this number there, is going to be the opposite of 1 squared plus 2 times 1 plus 8. 1's go there. Now let's evaluate. You're welcome to use your calculator for this. Notice that 1 squared is 1, and then we take the opposite, so that's negative 1 there. 2 times 1 is 2, plus the 8. So in the end here, we end up getting a positive 9. All right, so now we found the maximum height for both of these. Which fountain stream will reach the highest altitude? So fountain A will reach higher than fountain B. Now, however, you could even go, and I forgot to put an A there, you could even go into more detail by saying by a quarter of a foot. You don't have to be that specific, but it's helpful. All right, so this is our friend, the second part of 8.8-3. Fare thee well.